code as well as to screen sharing. So let's go to the question paper. Let me just see this thing's still sharing. Okay. So over here is the question from 2020, and the question says that a water is pumped to a height of 150 meters at a rate of 200 liters per minute. The efficiency of the pump and the 200 volts driving motor are 73% and 82% respectively. So we are going to have to now determine the current of the motor. So let's write down all the values that we have. So we have a height of so we have a height of 150 meters, and we have a flow rate of 200 liters per minute. 200 liters per minute, right? And we have an efficiency. Okay, we have a motor. So we have a motor of 200 volts, and the efficiency of 73%, and an efficiency of 82%. So the first question states that we need to find the current of the motor. So first we have to get the overall efficiency, which is going to be the efficiency 1 multiplied by efficiency of the second one. So we have 0,73 multiplied by 0,82, and then our overall efficiency, let me just get my calculator. 0,73 multiplied by 0.82. So we have an overall efficiency of 0.5986. So the question states that current. So the question wants is current of the motor. So they want the current of the motor. So first we're going to use these values to find power. So how are we going to find power? So we know that they are like two triangles, right? Who still remembers what are the triangles that we use for ELC? Does anyone still remember from the last lesson the triangle that we use? Can you guys still hear me? Okay. So our first triangle, very important, is Ohm's law, right? And then our second triangle is for power, which is current and voltage, right? So this question over here, this power outright is kind of the normal power formula that we use. So we know that power is equal
is
to
equal to
the
the
energy
energy
over
over
time, right?
time, right?
So we
So
know
we
to
know to
calculate
calculate
gravitational energy
gravitational
is
energy,
going
it's
to
going
be
to be
mgh
mgh
over
over
time, right?
time, right?
So the
So
power
the
out,
power out,
yes sir.
yes sir.
Okay, so we
Okay,
are
so we are
finding,
finding
the question
the
says that they
question
want the
states that they
current
want the
of
current
the
of the
motor.
motor.
So we first
So we
need to
first need to
find
find
the power
the
out
power out
before we can
before
find the
we can
current
find
of
the
the
current of
motor.
the motor.
And they have
And they
provided
have
us
provided
with
us
the
with
height
the height
and the mass
and the
and
mass
the
and
flow
the
rate,
flow rate,
and
and
we're going to
we're going to
use this
use this
equation
equation
to get the
to
power
get the
out.
power
So we
out.
have
So we have
200
200
200
200
liters per
liters
minute,
a
right?
minute, right?
And then we're going to
And then we're going to
multiply it
multiply
by
it by
9,81
9,81
multiplied by
multiplied
the
by
height.
the
What was
height.
the
What
height?
was the
It
height? The
was
height was
150
150
meters
meters
over
over
time.
time.
So this
So this
time is in
time is in
seconds, right?
seconds, right?
And this here
And
is
this
in
year is in
minutes. So we
minutes.
need to
So we need to
convert that to
convert that to
seconds,
seconds,
which is going
which
to
is
be
going to be
60.
60.
So
So
if I
if
punch
I
this
punch
into the
this into the
calculator,
calculator,
times
times
9.81 times
9.81 times
150
150
over
over
60,
60,
I get an
I get an
answer
answer
of
of
4905
4905
watts.
watts.
So that is
So that is
our
our
power
power
out.
out.
So
So
from
from
efficiency,
efficiency,
we know
we
that
know that
efficiency is
efficiency
equal
is
to
equal to
power out
power out
over
over
power
power
in.
in.
And what is our
And what is
input
our
power?
input
Our
power?
input
Our
power
input
is going
power
to
is going
be
to
the
be the
motor,
motor,
and our
and
output
our
power
output
is the
power is the
power of
power
the
of the
fluid.
fluid.
So this
So
is
this is
fluid
fluid
power.
power.
So
So coming back
this
to this
equation, we need
equation, we
to
need to
manipulate
manipulate
the
the
equation,
equation,
and
and
power
power
in is
in
equal
is
to
equal to
power
power
out
out
over the
over the
overall
overall
efficiency,
efficiency,
which
which
is
is
4905
4905
over the
over the
overall
overall
efficiency of
efficiency of
0,5986,
0,5986,
0,5986.
0,5986.
So when I
So
put
when
this
I
in
put
the
this in the
calculator,
calculator,
4905
4905
over
over
0.5986,
0.5986,
we
we
have
have
an
an
input
input
power
power
of
of
we have an
we
input
have an
power
input
of
power of
8194,11
8194,11
watts.
watts.
And we know from our
And we
triangle
know from our
that
triangle
power is equal
that
to
power
current
is equal
times
to current
voltage, right?
times
And what are
voltage,
we
right?
looking for? The
And
question
what are we looking
asked
for? The
us
question
to
asked
find the
us
current
to
of the
find the
motor.
current of the motor.
So we will write the
So we
current
will
is
write
equal
the
to
current is equal
power
to
over the
power
voltage.
over
So
the
our power
voltage.
here
So our
is
power here is
8194,11
8194,11
over the
over the
voltage. Our
voltage.
voltage was
Our voltage
given,
was
which
given,
was
which was, sorry,
200 volts,
200
right? So we're
volts,
going to
right?
put
So we're going to
200
put
volts
200
here,
volts here,
and we're going to
and we're
find
going to
our
find
current.
our current.
So
So
98194.11
98194.11
over the
over the
efficiency of
efficiency of
0,
zero,
no, over the
no, over
voltage
the
of
voltage of
200
200
equals to,
equals to,
so we have
so we
a
have a
40,97
40,97
amps.
amps.
So that is
So
our
that is
current.
our
So the current
current. So the
of the
current
motor
of the motor
is
is
40,97
40,97
amps.
amps.
Do you
Do
guys
you
have
guys
any
have any
questions
questions
on
on
getting the
getting the
amps
amps
for the
for the
motor?
motor?
Any questions,
Any
guys?
questions, guys?
Okay, so
Okay,
there
so there
is no
is no
question,
question,
so we're
so
going
we're
to
going
move
to move
on
on
to
to
the next question
the
for
next
question number
question for
one. So
question
the
number one.
question
So the
states that
question states that
the cost of
the
running the
cost of
motor
running the motor
for
for
24
24
hours per
hours
day.
per day.
Note that it's one
Note that it's
kilowatt
1 kilowatt
hour.
hour.
So it's going to
So it's
cost,
gonna cost,
it's going to cost
it's gonna cost
0.35
0.35
cents
cents
per
per
kilowatt
kilowatt
kilowatt hour.
kilowatt hour.
And this
And this
question
question
is very
is very
frequently asked
frequently asked
um,
um,
in most
in
of
most
the
of the
in most
in
of
most of
the
the
question papers.
question
Like they
papers.
like
Like
to
they
ask
like
this
to ask
question
this question
because I
because
think they
I
want
think they
students to
want
know how to
students to know
calculate
how to
um,
calculate
the operation
the
cost
operation cost
of
of
running
a
a
running
running an
a
appliance for a
running an
certain amount.
appliance for a certain amount.
Okay, so
Okay,
let's
so
see what is
let's
given.
see what
So
is given. So
are there any
are there any
persons taking
persons
note? Can
taking
I remove the
notes? Can
note?
I
Can I
remove the
remove this
note? Can I
question?
remove this question?
Is it okay if I
Is it okay if
remove the
I
question?
remove the question?
I'll just take a
I'll just take a
screenshot
screenshot
and send it
and
on the
send
group.
it on the group.
I think that's
I
best
think that's
to do a
best to
screenshot.
do a screenshot.
No
No
questions. Oh, let me
questions.
see the
Oh,
question.
there
Let
is
me
the
just
question. Let
respond
me
to
just
this
respond to this
question.
question.
Um,
Um,
so let's
so
remove
let's
what
remove
is not
what is not
needed
needed
from this
from this
question.
question.
So
So
now we
now
are
we
going
are
to
going to
question
question
P.
P.
So what is
So what is
given? So they're
given? So they're
saying
saying
14
14
hours.
hours,
14 hours a
14 hours a
day.
day,
And
and
so they want to
so
know,
they want to know.
the question
The
is,
question is,
um,
um,
you have to
you have
find
to
the
find
cost.
the cost.
Okay.
Okay,
And the given
and the
data
given data
is
is
so
so
it's for one
it's for
day
one
and
day
it's for
and it's for
14
14
hours,
hours,
and
and
the cost
the
is
cost is
0.34
0.34
kilowatts
kilowatts
per hour.
per hour.
Kilowatt hour,
Kilowatt
sorry.
hour, sorry.
0.35.
0.3.
So
So
if you forget the
if you forget
formula,
the
you know that
formula, you know that
kilowatts is
kilowatts is
power
power
and this is
and this
time.
is time.
And we know that
And we know that
power
power
is equal
is
to
equal to
energy
energy
over
over
time.
time.
So we're going to
So
have
we're
to
going to have
find
to find
the energy
the
first.
energy first.
So we're gonna
So we're gonna
multiply.
multiply.
We're gonna
We're gonna
we're gonna
we're gonna
multiply the
multiply
time
the
by
time by
power.
power.
So
So
energy is equal
energy
to
is equal to
power
power
multiplied by
multiplied by
time.
time.
Right?
Right?
So we have
So
a
we have
power
a
of
power
eight
of
one
816.
six. Oh, I remove the
I
power.
remove the power.
I think it
I
was
think
eight
it
one
was
six
816
one 9 4.
194.
Okay, I think it
Okay,
was
I
that
think it
much
was that much
multiplied by
multiplied by
time,
time,
which
which
is
is
14
14
hours.
hours.
Okay,
Okay,
so
so
we need to
we
get
need to
the
get the
same SI
same SI
units which
units
are
which
over
are
here.
over
So
here. Sorry.
we need to have the same SI unit, so that is in kilowatts. So we need to convert this to kilowatts, and then our answer will be 8.194 multiplied by 40, and then we get an answer of 1.114,716 kilowatt hours. So they want us to find the cost. So we know the cost is going to be in rands, right? So we're going to have to use SI units. So we have R equals to 0.35 over kilowatt hours multiplied by 114,716 kilowatt hours. So this unit and that unit is going to cancel. I hope you guys still remember dimension analysis. It's very important for the course and moving forward. So the final answer is going to be 0.35 multiplied by 4,716, and we have an answer of 40 rand, 15 per day. So that is how much it's going to cost per day. So the cost is going to be 40 rand, sorry, not 14 rand, 40 rand per day. So there you have it. So this is now the second question for question one. Do you guys have any questions? Are there any questions from students? Okay, so let's move on to the next question. Let's see if I can remove this. So let's get the next question. Question number two. Number two. Okay, so now we will be doing question number two from 2020 from 2020. So this is 2020 question paper. And the question paper states that calculate the length of the resistor of a circular wire used in a heating element connected to a 220 volt
220 volt
supply
supply
and a heat
and a heat
consumes
consumes
10 joules of
10 joules
energy
of
in
energy in
0.25
0.25
seconds.
seconds.
The resistor
The
element
resistor
is
element
made
is
of
made of
aluminum
aluminum and is
and it
and
has
it
a
has a
uniform
uniform
cross-section area
cross-section area
with a
with a
diameter of
diameter of
0.00016
0.00016
inches.
inches.
So they
So
want us to
they want us to
calculate the
calculate
length.
the length.
They want us
They
to
want us
calculate
to
the length
calculate the length this
of this
of this
wire.
wire.
So
So
this wire is
this wire is
like heating
like
elements.
heating
You would
elements. You
find
would
them
find them
inside of
inside of
your
your
geysers and
geysers and
kettles. I think
kettles. I think
if you open
if
up
you open
a
up a
kettle, you will
kettle,
see
you will
a heating
see a
element
heating element
at the
at the
bottom of your
bottom of
kettle.
your kettle.
That is what they're
That is what
asking
they're
for. They
asking
want
for.
to know
They
what
want
is
to
the
know what
length
is the length
of such a
of such
heating
a
element.
heating element.
So let's
So
write
let's
what
write
is given
what
to
is
us.
given
So
to
we
us.
have
So we
a
have a
voltage of
voltage of
220 volts.
220
We have
volts. We have
energy of
energy of
10 joules.
10
We
joules.
have
We have
time of
time of
0.25
0.25
seconds. We
seconds.
have
We have
a diameter
diameter
of
of
0.0016
0.0016
inches. Let's
inches. Let's
convert that
convert that
immediately
immediately
to
to
millimeters. So we're
millimeters.
going to
So we're
take
going to take
0, 0,
0,
0.016 multiplied by
multiplied by 25.4,
25.4 if I'm
25.4,
not
if I'm not
mistaken.
mistaken.
And then
Then
we
we
have
have
a value
a
of,
value of,
let me just
let me
change
just
this
change this
engineering
engineering
notation to
notation to
4, 0.064
4,064
millimeters.
millimeters.
Okay, so
Okay, so we have
a
a
we have a
we have a
diameter
diameter
of
of
we have a
we have a
diameter sorry
diameter
we
sorry
have a
we have a
diameter of
diameter of
4
4
millimeters.
millimeters.
Okay,
Okay,
so we know
so
that
we know that
this is the
this is the
resistivity of
resistivity
the
of
aluminium,
the aluminium,
and the best way
and the
to
best
solve
way
this
to solve
question
this
would be
question
to
would
find
be
the
to
power
find the
because we
power
have
because we have
energy and time.
energy and
So we're going
time.
to find the
So
power.
we're
So
going
we
to
know
find the
that the
power. So we
power
know that the power
is equal
is
to
equal to
energy
energy
over time.
over time.
So the energy
So the
is 10
energy is 10
joules
joules
over time, which is
over time, which is
0.25
0.25
seconds.
seconds.
And then we
And
have
then
a
we have a
power of
power of
40,
40,
let me just say 10
10
over
over
0.25.
0.25.
So our
So our
power
power
is equal
is
to
equal to
power is equal
power
to
is equal to
40
40
watts.
watts.
So that
So
is
that
our
is
power.
our power.
So
So
what are they
so what
asking us?
are they
They're asking
asking
us
us?
for
They're
the
asking us
length,
for the length,
and we know
and we
that
know that
the
the
resistance of the
resistance
wire is
of the wire
equal
is
to
equal to
is
the
equal to
is
the
equal to the
resistivity
resistivity
multiplied by
multiplied by
the length
the length
over
over
area.
area.
So they
So
want
they want
the length.
the
They want
length.
us to
They
find
want
the
us to
length.
find the length.
Okay.
Okay.
So we
So
have the
we have the
power.
power.
We have the
We have the
volts.
volts.
So we are
So
going
we
to
are going to
use
use
our power
our power
triangle, right?
triangle, right?
Remember our power
Remember our power
triangle
triangle
that we used in the previous question. So we know
that we
that the
used in the
power
previous
is equal
question.
to
So we know that the power
um,
is equal to
current times the voltage, right?
current times the voltage, right?
But we
But
don't want
we
the
don't want
current,
the
we want
current, we
the
want the
resistance.
resistance.
So we're going
So
to
we're
have
going to
to
have to
manipulate
manipulate
this
this
equation again.
equation again.
To
to
manipulate this
manipulate
question,
this
you
question,
can
you can
remember the
remember
other
the other
triangle for
triangles for
power,
power,
or you
or
can
you
just
can just
use Ohm's
use
law,
Ohm's
which
law,
is
which is
voltage is
voltage
equal
is
to
equal to
current times
current times
resistor,
resistor,
right?
right?
So we
So
know
we
that the
know that the
current is
current
equal
is
to
equal to
the voltage
the
over the
voltage over the
resistor.
resistor.
So over
So
here,
over
our
here, our
power is going
power
to
is going
be
to be
voltage is
voltage
going to be
is going
okay.
to be okay.
Let's do it like
Let's
this:
do it like this.
current
Current
times
times
voltage. So
voltage.
then
So
we know
then
that our
we know that
current
our
is
current is
voltage
voltage
over
over
resistor
resistor
multiplied by the
multiplied by the
voltage.
voltage.
So
So
our final
our final
equation will
equation
be
will be
voltage
voltage
squared
squared
over the
over the
resistor,
resistor,
right?
right?
So now
So
let's
now
use
let's
this
use this
formula. Sorry,
formula.
let's
Sorry,
use this
let's
formula.
use this
So we
formula.
know that
So we know that
power is equal
power is
to
equal to
voltage squared
voltage squared
over the
over the
resistor,
resistor,
and we are
and we are
looking
looking
for the
for the
resistor.
resistor.
So
So
let's
let's
manipulate this
manipulate this
formula, and
formula,
the
and
resistor
the
is equal
resistor
to
is equal
voltage
to
squared
voltage
over the
squared over
power.
the
So we
power.
have
So we have
let's see,
we have the
we have
power,
a
we
power
have a
sorry
power, sorry,
we have a
we
voltage
have a
of
voltage of
220
220
squared
squared
over
over
the power
the
of
power of
40
40
watts.
watts.
So our
So
resistance is going
resistance
to
is going to
be,
be,
get the
get the
calculator,
calculator,
220
220
squared
squared
divided by
divided by
40
40
watts, which
watts,
is
which is
equal to,
equal to,
so our
so
resistance is going to be
resistance is going to be 120 10
ohms.
ohms.
That is our
That is our
resistor.
resistor.
So let's
So
remove
let's
this.
remove this.
Number 2,
Number
our
2, our
resistance is
resistor is
equal to
equal to
1 to
1 to
10
10
ohms.
ohms.
So
So
we have the
we have the
resistor,
resistor,
where
we have
we have the
we have the
resistance,
resistance,
we have the
we have the
resistivity.
resistivity.
So we need to
So we need
find
to
the
find
area,
the area,
and we all
and we
know
all
the
know
area
the
of a
area of a
circle,
circle,
right?
right?
Sorry.
Sorry.
So we
So
have
we
a
have
wire,
a
right?
wire, right?
And the
And
cross
the cross
section
section
area of
area
this
of
wire
this wire
is equal
is
to
equal to
pi over
pi over
4
4
d
d
squared,
squared, which is equal to
pi over
pi over
4
4
d
d
squared.
squared.
So
So
our d
our
is
d
4
is 4
millimeters, and we
millimeters,
need
and we
to
need to
convert it to
convert it
meters.
to meters.
So it's going to be
So it's going to
4
be
times
4
10 to the
times 10 to the
minus
minus
3,
3,
10 to the minus
10 to the
3.
minus 3.
Wait, let me
Wait,
just
let me just
double
double
check
check
this
this
quickly.
quickly.
Okay,
Okay.
meters,
Meters,
right?
right?
Sorry guys, let me
Sorry
just
guys, let
check
me just check
the
the
conversion of this
conversion of this 0 comma
0.00,
0 0
0 comma 0
0 comma
0,
0 0
0 comma 0
0
0,
comma 0 0
0
0 0
0.016
1 6
multiplied by
multiplied by
25.4
25.4
equals to,
equals to,
oh sorry guys,
oh sorry
so
guys,
this
so
question
this
here,
question here,
it's
it's
actually
actually
times 10
times
to the
10
minus
to the
3
minus 3
times 10 to the minus
times 10 to
3
the minus 3
millimeters.
millimeters.
So then
So
this
then
answer
this
is going to
answer is
be
going to be
minus
minus
6.
6.
So we're going to
So
put
we're going to
4
put 4
times 10 to the
times 10
minus
to the
6
minus 6
squared,
squared,
and we're going to get
and
an
we're going to
area
get an
of,
area
let me
of,
just put it in
let
the
me just put it in
calculator,
the calculator,
pi over
pi over
4
4
d squared,
d squared,
so d
so
is
d
4
is
times 10 to
4
the
times
power
10 to the power
negative
negative
6
6
squared back,
squared back,
and we're going
and
to
we're
get
going
an
to get an
answer of
answer of
1,29
1,29
times 10 to the
times 10
minus
to the minus
11
11
meters
meters
squared.
squared.
That is
That
our
is our
that is our
that
area.
is our
So
area. So
it is
it
equal to
is equal to
1,29 times 10
1,29
to the
times
minus
10 to the
11
minus 11
meters squared.
meters squared.
So we have
So
our
we have our
area as
area
well.
as well.
The question
The
wants us
question
to
wants us
find
to
the length
find the
of
length of
the
the
wire, right?
wire, right?
So let's
So
write that
let's write that
formula.
formula.
Let me just
Let
copy
me
this
just
formula. Copy,
copy,
paste.
paste.
So
So
the length,
the length,
the
the
the length
the
of the
length of the
wire
wire
is going to
is
equal
going to
to
equal to
the
the
resistance
resistance
multiplied by the
multiplied by the
area
area
divided by
divided by
the
the
resistivity. So
resistivity.
let's
So let's
get all the
get
values
all the
here.
values
Our
here. Our
resistance of the
resistance of
wire
the
is
wire is
1
1
to
to
10
10
ohms
ohms
times by
times by
the area of
the area of
1,29 times
1,29
10 to
times
the
10 to
minus
the minus
11
11
over
over
our
our
resistivity
resistivity
is
is
aluminium. So
aluminium. So
resistivity of
resistivity of
aluminium is
aluminium is
2,8
2,8
2,825 times 10 to the
2,825
minus
times 10 to
6
the minus
ohms
6 ohms
centimeters
centimeters
squared. So we need to
squared. So
convert
we need
that
to
as
convert
well
that as well
to
to
meters.
meters.
So we know
So we
that
know that
this is centimeters. We need to
centimeters, we
convert
need
that.
to convert that.
So we know
So we
that
know that
um,
um,
100 centimeters
100
is equal to
centimeters is
1
equal
meter.
to 1 meter.
So
So
if we have
if we have
centimeters, we're going to
centimeters,
have
we're
to
going to have to
multiply by
multiply by
1000. I'm sorry,
1000. I'm sorry,
100.
100.
So our
So our
resistivity is going
resistivity
to
is
be
going to be
2,875
2,875
times 10 to the
times
minus
10 to
8.
the minus 8.
And the length
And
of
the
our
length
wire will
of our
be
wire will be
1230. Let's see if I
1230.
got the
Let's see if
resistivity
the
here.
resistivity.
So we have
So we
to the
have
negative
to the negative
6 times
6 times
negative 6, right?
negative 6, right?
By divided
By
by 100.
divided by
So we're going
100.
to get
So we're gonna get
negative 8.
negative
Okay.
8. Okay.
So now
So now
we have to
we
punch
have
this
to
into our
punch this into our
calculator.
calculator.
So it's going to be
So it's gonna be resistance
multiplied by area of 1 comma
1 comma
2
2
9 times 10
9
to the
times 10
power
to the
of
power
negative
of
11
negative 11
over
over
2.875 times
2.875 times
10 to the
10
power
to the
negative
power
3
negative 3
equal to.
equal to.
So
So
the length of
the
the
length
wire
of
is
the
equal
wire is
to
equal
0
to
comma
0 comma
546
546
meters.
meters.
So that
So
is
that
now
is
the length
now the
of
length
the
of the
wire. So
wire.
the length
So
of
the
the
length
wire
of
is
the wire
equal
is
to
equal to
0 comma
0 comma
546
546
meters.
meters.
Mm,
Mm,
do you guys
do you
have
guys have
any
any
questions
questions
on this
on
topic?
this topic?
So I see
So
you
I
guys
see
don't
you
have
guys don't
any
have any
questions on the
questions on
topic.
the topic.
So let's
So
move
let's
on
move on
to
to
the next
the next
question.
question.
Okay, so let's
Okay,
go
so let's
on
go
to
on to
I forgot to
okay.
tell
I
you
forgot to
guys
tell you
that I
guys
think this
that
is
I think
chapter
this is
one,
chapter 1,
if I'm not
if I'm not
mistaken.
mistaken.
And then this
And then this
question
question
is
is
also maybe I think
also
it's also
maybe I
chapter
think it's also
one.
chapter 1.
I think it's
I
called the
think it's called the
basics.
basics.
So I think
So
question
I
three
think
might
question 3
be
might be
different from
different from
question one and
question
two.
1
So
and
let's
2. So
go and
let's go and
find question
find
number
question
three.
number 3.
Let me just
Let me
copy
just
question
copy
number
question
3
number 3 quick
and let me
and
move
let
it
me move
here
it
to the
here
note.
to the note.
To your
To your
notes,
notes.
where
Wait,
your notes?
where's my notes?
So I'm sorry for that.
Sorry
I
for
think
that.
it
I
did
think
not
it did
copy the
not copy the
question.
question.
So I just
So I
want
just
to copy this
want to
question
copy this question.
again. Um,
Um,
I don't know what's happening, but
I
it's
don't know
not.
what's happening, but it's not.
Let me just
Let
copy
me
this
just
question
copy this
again
question
because it does not want to copy this
again
question.
because it does not want to copy this question.
Hopefully it'll copy this question. Let's see question number
Hopefully to
3.
copy this question. Let's see question number 3.
Copy.
Copy.
Okay.
Okay.
Okay. So we
Okay.
have question
So we
number
have
3
question number 3
in front of
in
us.
front of
Let me
us.
just
Let me just
enlarge the
enlarge
screen.
the screen.
So the
So
question in
the
front of
question in
us
front of us
says that
says that
a
a
DC
DC direct current
a direct current motor after running for
a
several
direct current
hours
motor
on
after running
consistent
for several
mains
hours
of
on consistent mains of
400 volts
2
takes a
to
field
400
current
volts
of
takes a field current of
1,6 amps
1,6 amps if
if the temperature rise is
if the
known to
temperature
be
rise is known to be
400
400
40
40
degrees.
degrees.
What value of
What value of
extra
extra
circuit resistance
circuit
is
resistance
required to
is
adjust the
required to
field
adjust the field
current to
current to
1,6 amps
1,6
when
amps when
starting from cold
starting from
at
cold at
20 degrees?
20 degrees.
The temperature
The
coefficient
temperature
of the
coefficient
motor
of the motor
material is
material is
0,043
0,043
um,
um,
per Kelvin
per
at 20
Kelvin at
degrees.
20 degrees.
No, wait,
No,
sorry.
wait, sorry.
The material is
The material is
0,043
0,043
at
at
20 degrees.
20 degrees.
So that
So
this here is the
that
coefficient
this
of
here
the, it's a
is the
constant of
coefficient
the
of the, it's a
material.
constant of the material.
So let's solve
So
this
let's
question.
solve this question.
Let's write all the givens.
Let's write
So the
all the
voltage
given.
is equal
So
to
the voltage is
400
equal to
volts.
400
We have an
volts.
amp
We have
of
an amp of
1,6 amps,
1,6
and we
amps,
know that the amps
and we know
remains
that the amps
constant,
remains constant,
and
and
the change in
the
temperature
changing
is
temperature
40
is
degrees
40 degrees
Celsius.
Celsius.
So I think this
So I
question
think this
is
question is very,
very simple to
very
solve.
simple to
It
solve.
is a
It
basic
is a basic
wire question,
wire
and
question,
the only
and the
factors
only factors
that are
that are
changing is
changing is
temperature.
temperature.
So the only thing
So the only
changing
thing
of this
changing
wire
of this
is
wire is
temperature.
temperature.
So
So
let's
let's
use,
use,
I hope you guys
I hope you guys
remember
remember
the formula,
the
which is R1 is equals to
formula, which is R1 is
R
equal to
at
R at
R.
R.
So R1
So
is equal to
R1 is equal to
R0
R0
1 plus
1 plus
alpha
alpha
and temperature.
and
So this is the
temperature. So this
coefficient
is the
over here of
is
the
the
material
coefficient
itself,
over here of the material itself,
and that temperature will be
and that temperature will
temperature
be
1. So
temperature
temperature 1
1. So
1
temperature 1
sorry
1
1 1
sorry
1
1 1
1 and 0, sorry
1
1
1
and
and 0,
0,
sorry 1 and
and then
0,
this is 0.
and then this is 0.
So we are looking for
So
this.
we are looking
So the
for
resistor
this.
1 is going to be
So the resistor
40
1 is going to be
degrees,
40
and then this is going
degrees,
to be
and
20
then this is
degrees,
going to be 20 degrees,
right?
right?
So this is
So this is
ohms, and that is
ohms,
ohms.
and that is ohms.
So let's solve
So
the
let's
equation.
solve the
So we
equation.
first need
So
to
we
find
first need to find
the
the
resistor.
resistor.
So we know from the triangle that voltage is
So
equal
we
to
know
current
from the
times
triangle that
resistor.
voltage is equal to current
So voltage
times
is equal to
resistor.
current multiplied by
So
resistor,
voltage is equal to
or
current
resistor is going to
multiplied by
equal to
resistor,
voltage
or
divided
resistor
by
is going to
current,
equal to
which is
voltage
400
divided by
volts
current,
over the
which
current
is
of
400 volts
1,6
over the current of
amps. And when I
1,6
punch this
amps.
into the
And when I
calculator,
punch this into the calculator,
400 divided by
400
1.6
divided
amps is
by
equal to
1.6 amps is equal to
250 ohms.
250 ohms.
So, sorry,
So, sorry.
ohms. So we know that the
So we know
resistor
that
1 is equal
the
to,
resistor
so
1
we
is
have
equal
this
to,
value,
so we have this
this value is
value,
given,
this value is
and
given,
this temperature
and this
is also
temperature
given. So we have
is
a
also given.
resistor
So we
of
have a resistor of
250
250
ohms.
ohms.
So the question
So the
is
question
asking us, what is
is
the question
asking us,
asking
what is
us?
the question
Okay, so the
asking us?
question, what
Okay, so the
value of
question,
extra
what
circuit
value
resistance
of
is
extra
required to
circuit
adjust the field?
resistance is
Okay,
required to adjust the field?
so they want to
Okay,
know
so they want to know
resistance
resistance
extra.
extra.
So let's
So
calculate
let's calculate
the initial
the initial
resistance.
resistance.
So it's going to be
So it's going
R1
to be
equals to
R1
R
equals to
initial
R
1
initial
plus
1 plus
times temperature,
times
the
temperature,
coefficient
the
of the
coefficient
material
of the
times
material
temperature.
times the temperature.
So it's
So
going to
it's
be
going to be
R equals
R
to
equals to
250,
250,
250 which is
250 which
calculated
is
over
calculated
1
over
plus
1 plus
the
the
coefficient of the
coefficient of
material
the
is
material is
0,043
0,043
0,043 multiplied by
0,043 multiplied
what?
by
Multiplied by
multiplied
the
by
rising
multiplied
temperature
by
for,
the rising
because this here is
temperature
40,
of,
right?
because this
So
here is
this T is
40,
going to
right?
be 40 as
So
well.
this T is going
So
to be 40 as well.
40
So
degrees Celsius.
40 degrees Celsius.
Then we get a
Then
temperature
we get a
of
temperature of
250
250
over 1 plus
1 plus
0.043 multiplied
0.043
by
multiplied by
40 degrees,
40 degrees,
and then our
and then
answer
our answer
therefore this equation
this
will
equation
be
will be
91,
91,
comma 911
911
ohms.
ohms.
Oh, sorry guys,
Oh,
I
sorry
think I made a
guys, I think
mistake
I made a
over
mistake
here.
over here.
Here should
Here
be
should be
0, comma
0,
0,
0,
0, comma 0,
0,
0, comma 0,
0,
0, 4,
0,
3,
4, 3,
0, comma 0, 4,
0,
3,
4, 3,
and then our
and
answer
then our
here
answer
would
here
be
would be
213, comma 31
213,31
ohms.
ohms.
So that would be
That would be
the temperature
the
of
temperature
the resistor at 40
of
degrees,
the
right?
resistor at 40 degrees, right?
So let's
So
calculate
let's
the
calculate the
difference, the
difference,
change
the
in
change in
the extra
the extra
resistance, right?
resistance, right?
So the change in
So the
resistance
change in
is going to
resistance is
be
going to be
250 ohms.
250 ohms.
Let's do this.
So
Resistor
this
1
is the 1
minus
minus
resistor
resistor
initial.
initial.
So
So
okay.
okay.
So
So
this
this
temperature is
temperature
at 20
is at
degrees.
20
This
degrees. This
resistance is at
resistance
20
is at
degrees.
20 degrees.
And as we
And as we
use
use
the motor,
the motor,
the temperature
the temperature
rises to
rises to
40
40
degrees. And
degrees.
because the temperature rises,
And
the
because the
resistance
temperature
also
rises, the
increases.
resistance also
So they want us to find
increases.
the
So
extra
they want us to
resistance,
find the
right?
extra
Or
resistance, right?
the difference
Or the
between
difference between
40 and 20.
40 and
So
20. So
the resistance at
the
40
resistance
is
at 40 is
250 minus
250
the
minus the
213,31
213,31
ohms, and our
ohms.
final
And our
answer
final
would
answer
be
would be
3.
3.
Let me just put this
Let
in
me just put this
calculator.
in calculator.
250 minus
250 minus
31,
31,
37
37
ohms.
ohms.
So that is
So
the
that is the
resistor over
resistor
here.
over here.
So what is the
So
value
what
of the
is the value of the
resistor?
resistor?
37
37
ohms.
ohms.
So there you have it. That
So
is
there you
the
have it.
third
That is the
question
third question
for 2020.
for 2020.
Are there any other
Are there
questions?
any other
Do you guys have
questions?
any other
Do you
questions
guys have any other
for
questions
what I just did? Are
for
you
what I
guys
just
okay
did?
with
Are you guys
what
okay
was
with
done?
what was done?
Okay, so
Okay,
I
so
think
I think
question number
question
4
number
will be
4 will
our
be
last
our
question
last
for
question for
the class,
the class, and then we will be
and then I'll be taking
and then I'll be
questions
taking
from you
questions
guys,
from you
and
guys, and
we'll
we'll
continue
continue
we'll
we
continue
will
with
continue with
the
the
question paper
question paper
at
at
half
half
past one.
past one.
So I'm going
So I'm
to
going to
solve the
solve
last
the last
question, question number
question number
4,
4,
and
and
after
after
the break,
the break,
after we're going
after
to
we're
take
going to take a
30-minute break,
like a 30
and after
minute
the
break,
break we are going
and
to
after the
continue.
break
So
we are going to continue. So
that's question 5, and
that's
then
question
6,
5, and then
and
6, and
7.
7.
Oh, and there's an 8,
Oh,
and
and
there's a
there's an
9 as
8, and
well.
there's a 9 as well.
So I think this
So I
question
think this
paper
question
is
paper
about
is
3
about
hours.
3 hours.
Let's see. I think this
Let's
question
see.
paper
I think this
is.
question paper is.
Oh,
Oh,
wow. So this question paper
So
was
this
done
question paper
during
was done during
COVID, and
COVID, and
they had 2 days to
they
do
had
this
two
question
days
paper.
to do this
So
question paper. So
yeah,
yeah,
must have been lucky, right?
must have been
two
lucky, right?
days.
2 days.
But I think it should
I
be
think it should be
2 hours.
2 hours.
Should be two
Should be
hours
two
for you guys
hours for you
to.
guys
Sorry, not two
to.
hours.
I'm sorry, not 2 hours.
3 hours
3 hours
for
for
this question
this
paper.
question
That
paper.
should
You guys
take
should
about three
take about three
hours for this
hours
question
for
paper.
this question paper.
So let's
So
do
let's
question
do
number
question
4.
number 4.
Kirchhoff, Kirchhoff's law.
Kirchhoff's law.
I think in the
I think
next
in the
semester you
next
guys
semester you
will be
guys will
doing
be doing
other laws as
other
well,
laws
such
as well,
as
such as
I think
I think
Strivelin and
Strivelin and
superposition, something like that.
superposition, something like that.
Yeah,
Yeah,
so it is
so
kind of
it is kind
confusing,
of
but I would
confusing, but
recommend
I
that
would
you do
recommend
not
that you do
focus
not
on
focus on
studying these laws,
studying these
and
laws, and
because there's a lot of other
because there's a
questions
lot of
that you
other
guys
questions that you guys
can understand and are
can
able to solve.
understand and are able
So
to
don't
solve.
make the mistake and
So
focus
don't make
on
the
these
mistake and
laws
focus
during the
on
second
these
semester. I
laws
would
during the
advise you
second
to
semester. I would
focus on
advise you
all the
to
other chapters
focus on
equally.
all the other chapters
And
equally.
then if you have like
And
extra
then if you
time
have like
to
extra
study the
time
other
to
laws.
study the other
But I
laws,
think for
but
my
I think
question
for
paper
my
that I
question
did
paper that I
when I
did
was
when I was in
in school,
school,
university, I think they
university,
did ask
I think
us
they did
to
ask
at
us
least know
to at
two of
least know two
the
of
laws. So
the
the
laws.
question
So the question
might be,
might be,
for example,
for example,
um,
um,
solve this using
solve this
Kirchhoff,
using
since
Kirchhoff,
everyone knows how
since
to do
everyone knows
Kirchhoff's
how to do
law.
Kirchhoff's law.
The next
The
question would
next
then
question
be
would then be
solve using
solve
another
using
method
another
to
method
confirm
to
your answer.
confirm your answer.
So you should be
So
able
you
to at
should be
least
able to at
know
least know
two
two
methods,
methods,
but other
but
than that,
other
it's
than
not
that, it's
really
not really
a must.
a
But
must.
it's
But
best
it's
that
best
you
that
guys
you
focus
guys
on all the
focus on all
chapters
the
equally
chapters
before
equally
studying
before studying
all the laws
all the
and
laws
confusing
and
yourself.
confusing yourself.
So,
Um,
let me just move this
Let me
question
just
a
move
bit
this
lower.
question a bit lower.
Okay, so let's
Okay,
look
so
at
let's look at
Kirchhoff's law.
Kirchhoff's law.
So what does
So what does
Kirchhoff's law?
Kirchhoff's law?
Does anyone
Does
want
anyone
to
want to
answer,
answer,
like try
like
and
try
explain
and
what
explain what
Kirchhoff's law
Kirchhoff's
is?
law is?
Okay, so
Okay,
like
so
looking
like
at this
looking at
question,
this
right?
question, right?
So
So
the basic
the
law
basic
of
law of
conservation of
conservation
energy,
of
I think it's
energy.
the
I think it's
first
the
law
first law
that
that
states that
states that
energy cannot
energy
be
cannot be
created or
created or
destroyed, right?
destroyed, right?
So
So
we have to
we have to
know that
know that
the sum
that
of
the
all
sum
the
of all the
voltages
voltages
that is
that is
inside the
inside the
circuit is equal
circuit
to the
is
sum
equal
of
to the
all
sum
the
of all the
voltages
voltages
out of the
out of the
circuit,
circuit,
right?
right?
So we have to
So
know
we have
that
to know that
this is kind of
This is kind
Kirchhoff's
of
law
Kirchhoff's law.
summarized. Like this is
Summarize
how
like
I
this is
would
how I
summarize
would
Kirchhoff's
summarize
law, right?
Kirchhoff's law, right?
And we
And
know that the
we
voltage
know
is
that the
equal
voltage
to
is equal
current
to
times the
current times
resistor,
the
right,
resistor, right,
from the
from the
triangle.
triangle.
So the
So
question states
the
that
question states
calculate the
that
current
calculate the
through
current
the
through
30
the
ohm
30 ohm
resistor using
resistor
Kirchhoff's
using
law,
Kirchhoff's law,
showing all the
showing all
steps.
the steps.
So they want
So
the
they want the
current over
current
here,
over here,
right?
right?
So we know
So
that
we know that
we going to
we
say
going to
that
say that
I okay, let me
I
just
okay, let
make
me just
this
make
a bit
this
larger,
a bit
erase all
larger,
these notes.
erase all these notes.
Let me just
Let me
increase the
just
size of
increase the
this thing.
size of this thing.
So
So
okay,
okay.
so
So
for this
for this
question
question
we are going
we are
to
going to
say that the
say
current
that the
one
current one
flows through the
flows
circuit,
through the
right?
circuit, right?
And at this
And at
point
this
the
point
current
the
has to
current has
divide.
to divide.
So we're going
So
to
we're
say
going to
that
say that
this is going to
this is
be
going to be
I2
I2
and this
and
here is
this
going to
here is
be
going to be
I3,
I3,
right?
right?
And over
And over
here
here
we know that the
we know
current
that the
has to
current has to
divide on
divide
both
on both
sides,
sides,
right?
right?
And over
And
here
over
is going
here
to
is
be
going to be
I1.
I1.
Over here it's
Over
going to
here
be
is going to be
I2.
I2.
Okay.
Okay.
So to understand
So
Kirchhoff's
to
law, we
understand
have
Kirchhoff's
to
law,
break
we
the
have to
circuit
break the
down
circuit
to like
down to like
components, right?
components,
So
right? So
I'm going to break
I'm
the
going to break
circuit
the circuit
and
and
sorry, the
sorry,
other battery
the other
9
battery
volts
9 volts
and
and
25. Oh,
25.
we have two
Oh, we have
batteries.
two
Okay, so we have
batteries.
another
Okay, so we have another
battery over
battery
here
over here
and a battery over
and a
there.
battery over there.
Okay,
Okay.
so we
So
know
we
that
know that
when batteries
when
are
batteries
in
are in
series, we
series,
add
we
them,
add them,
right?
right?
But if the
But if the
batteries
batteries
are in
are in
opposite
opposite
directions,
directions,
we have to
we have to
subtract them.
subtract them.
So I should draw
So I
it a
should
bit
draw it a bit
bigger
bigger
and
and
25
25
volts
volts
and
and
12
12
ohms
ohms
down
down
45,
45,
30.
30.
Okay,
Okay.
so we're going
So we're
to
going to
solve
solve
this
the
circuit
circuit
first.
first.
Number one,
Number one,
right?
right?
So let
So
me just
let me
label
just
this
label
for
this
you guys.
for you
So
guys.
this
So
point
this
here
point
is known
here
as
is known
A,
as A,
and then this
and
point
then
is
this
known
point
as
is known
B,
as B,
and
and
this point
this
should
point
be
should be
C,
C,
and
and
G,
G,
H,
H,
and I.
and I.
So we
So
can
we can
see
see
that
that
sorry,
sorry,
we can see that
we can see
here
that
is a
here
negative
is
and here is
a
also a
negative
negative
and here is also a negative
on both sides.
on both sides.
So we're going to have to
So we're
solve
going to
this
have to solve
first. This
this
is our first
first.
loop, so
This
we
is
have
our
to solve this
first loop.
first loop.
So we have
Remember that I
to
said
solve
that
this first loop. Remember that I said that
the sum of the voltage equals the sum of the
the sum of
voltage.
the voltage
So now
equals the
we're
sum of the
going to
voltage.
do the sum of the
So now
voltage
we're
over
going to
here
do the
and
sum
the
of the
sum of the
voltage over
voltage over
here
there,
and the sum of the
as
voltage
well
over
as
there,
voltage
as
is
well
equal to
as
current times
voltage is equal
resistor.
to current times
So the
resistor.
voltage here
So the
is
voltage
9
here is 9
is equal to
is equal to
equal to
to
25 volts,
25 volts,
and then we're going to have to,
and then we're going to have to,
sorry guys,
second, sorry guys,
um, I'm just
I'm
getting a little,
just
let me
getting a little,
just,
let me just,
okay, so
okay, so
left hand side and
left
right
hand
hand side.
side and
So on
right
our
hand
left
side.
we have
So on our left we have
9 volts and
9
we have a
volts
12
and we have
ohm
a 12
resistor.
ohm
So
resistor. So
we're going to have
we're
to
going
put,
to have to put,
so we know that
so we know that
the volt is
the
positive
volt is positive
minus
minus
um,
um,
I
I
or
or
wait, let me just
wait,
do this.
let me just do this.
From this side and
From
that
this
side,
side
okay.
and that side,
So we
okay.
have
So we have
V1 plus
V1 plus
V2 equals
V2 equals
V3
V3
plus
plus
V4.
V4.
So
So
V1 is
V1 is
9
9
volts.
volts.
V2 over
V2
here
over
is going
here
to
is
be,
going to be,
so this is going to be
so this is going to be
positive because
positive because
it's a power
it's a
source.
power source.
Then it's going to
Then
be
it's going to be
negative.
negative.
This is a
This is a
resistor, so it's
resistor, so
negative.
it's negative.
To get
To get
voltage, we
voltage,
know that
we know that
the current times
current
resistor
times
equal to
resistor
voltage.
equal to
So we
voltage.
have
So we have
12
12
ohms
ohms
multiplied by
multiplied by
the current,
the
which is
current, which is
I1,
I1,
equal to,
equal to,
so the
so
voltage
the
on this
voltage on
side,
this side,
sorry,
sorry,
the voltage on
the
this
voltage
side
on
is
this side is
25.
25.
So we have
So we have
25
25.
voltage 4.
Voltage 4.
So this
So
here is
this
going
here
to
is
be
going to be
voltage 4.
voltage 4.
So to
So
calculate
to
voltage
calculate
4,
voltage
we're
4,
going to
we're going to
minus
minus because
this
it's
voltage, right?
voltage, right?
So
So
current times
current times
resistor.
resistor.
So
So
sorry,
sorry,
we see that these
we see that
resistors
these
are in parallel, and we
resistors
know that
are in parallel,
resistance in parallel
and
is
we know
equal
that
to 1 over
resistance in
R
parallel is equal
plus
to
1
1
over
over
R
R plus
power
1
minus
over
1.
R
So let me just calculate
power
the
minus 1.
resistor
So let me just calculate
in
the
that circuit.
resistor
So then
in that
is
circuit. So it's going to be
41 over
1
45
over
plus
5 plus
over 50
over 50
power of minus 1.
power of minus 1.
So the resistor
So the
in that
resistor
circuit is going
in
to
that
be
circuit is going to
18.
be
So let's remove
18.
this
So let's remove this
and let's put an
and let's
18
put an 18
ohms. So we have
ohms. So we have
18
18
minus the current.
minus the current.
Our current
Our
is
current is
I3. So
I3.
it's going to be
So it's
I3.
going to be I3.
So let's
So
let's get
let's
the voltages
let's
on one
get the
side. So it's going
voltages
to be
on one
9.
side. So it's going to be
9
9.
minus
9 minus
25
25
equal to
equal to
12 minus
12
18.
minus 18.
Sorry,
Sorry,
12
12
I1 minus
I1 minus
18
18
I3. So
I3.
we have
So we
a
have a
16.
16.
9 minus
9 minus
25 equals
25 equals
negative 16
negative 16
volts is equal
volts
to
is equal to
12
12
I1 minus
I1 minus
18 I3.
18 I3.
We know that this is our
We
bigger
know that
voltage, right?
this is our bigger
So
voltage,
we
right?
can say that
So we can say that
I2 is equal to
I2 is equal to
I1 plus
I1
I3.
plus
So this will
I3.
be equation
So
number
this will
1.
be
Very
equation number 1.
important.
Very important.
Okay.
Okay.
And
And
we can see that
we can see
this
that
circuit is
this
parallel
circuit
to this
is
circuit.
parallel to this circuit.
So
So the voltage is going to be equal.
So let's move on to the
So
next
let's move on to the next line.
So we
So
solved
we solved
the small one.
the
So
small
now
one.
let's move
So
on
now
to
let's
the
move
big one.
on to the big
So the
one.
big one is going
So
to
the big
be
one is going to
9
be
volts,
9 volts,
12 ohms,
12 ohms,
and then 10
and then
ohms
10
over here
ohms over
and
here
back there.
and back there.
So now we are doing
the
big one, right? It's
yeah.
So now we know
Now
that
we know that we need to
use the
use the
conservation
conservation of the voltages.
Conservation of voltages. So we know this is I1, and by 10
it's going to be
I2.
I2.
Okay,
Okay,
and
it's going to be I1
over
over
here.
here.
So
So let's do the
mathematics.
mathematics.
So we're
So
going
we're going
to
to
solve
solve
this
this equation and do
9 volts is equal
is equal to
minus 12 I1
equal to.
So this is
So
on
this
our
is
left
on
hand
our left
side
hand side
and this is on
and
our
this
right
is on
hand
our
side.
right hand side.
So, wait.
Wait.
So now
So
on
now
our right
on
hand
our right
side
hand side we have a
10
10
ohm
ohm
and our
and our
current
current is
I2,
I2,
and we know
and
that
we know that
I2 is
I2
equal
is
to
equal to
I1 plus
I1 plus
I3.
I3.
So
So
let's do
let's
this.
do this.
9
9
volts
volts
equals to
equals to
12 plus
plus
10
10
I1. So
I1. So
I1
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 plus
plus
10
10
I3.
I3.
So we
So
have
we have
a we're gonna
a
add like terms,
we're gonna
which
add
is
like terms, which is
22
22
I1
I1
plus
plus
10
10
I3,
I3,
9 volts.
9 volts.
So this here
So
is
this here
equation number
is
2.
equation number 2.
This is equation number
This
1,
is equation number 1,
2,
equation number 2,
and equation
and
number 3.
equation number 3.
So now we have
So
to
now
solve
we have to solve
this
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 this circuit over
this
here.
circuit over here.
So we have to solve
So
that
we have to
circuit
solve
over
that
there.
circuit over there.
It's on your
And it's on your
page.
page.
So it's
So it's
24 volts,
24 volts,
18,
18,
10.
10.
So we need to
So we
solve
need to
this one
solve this
over
one
here.
over here.
So
So
25. So we know we're going to do sum of the voltage
25.
equals sum of the voltage,
So
and
we
our
know we're going to
triangle
do
is
sum of the
voltage
voltage equals sum of the
current
voltage,
times
and our
resistor.
triangle is voltage equals
We have a
current times
current of
resistor.
3 here
We have a current
going
of
down,
3 here
and we have a
going
current of
down,
2 going down.
and we have a current of 2
And
going
we know
down.
that I2 is
And we
equal
know
to
that
I1 plus
I2 is equal to
I3.
I1 plus I3.
So why do we
So
add?
why do we
Because
add? Because
the voltage has to
the
divide.
voltage has to
Remember
divide.
that
Remember that
you have
you
I2
have
here,
I2 here,
and as it
and
travels,
as
it's
it
going to
travels, it's
divide
going to
into
divide
I1
into I1
and
and
I3.
I3.
So
So
I1 plus
I1 plus
I3 is
I3
going to
is going
equal
to
to
equal to
I2.
I2.
Okay, so
Okay,
let's
so
solve
let's
this
solve this
equation.
equation.
Going to use
Going to
this.
use this.
So
So
on our right
on
hand
our right
side we
hand
have
side we have
25
25
minus
minus
18 because
18
this is a
because this is a
resistor
resistor
times
times
I3.
I3
I3 equal
I3
to
equal to
10
10
I2.
I2.
So we know
So
that
we know that
I2 is
I2
equal to
is equal to
I1 plus
I1 plus
I3.
I3.
And we're going
And
to
we're going
do
to do
25
25
equals to
equals to
18
18
plus
plus
10
10
I3,
I3,
18
18
I3
I3
plus 10
plus 10
I2.
I2.
So we
So
have we have
we have
28
28
I3 plus
I3 plus
10
10
I2,
I2,
25.
25.
So now
So
we have
now we have
another
another
equation.
equation.
This is going to
This is
be
going to be
equation
equation
number 4.
number 4.
So that's
So
equation
that's
number
equation
4.
number 4.
And that's equation
And
number
that's equation
3.
number 3.
That's equation
That's
number
equation
2.
number 2.
And that's
And
equation
that's
number 1.
equation number 1.
So now
So
we're
now
going to
we're
have to
going to have to
solve
solve
for
for
our
our
currents,
currents,
right?
right?
So
So
um we have
we have
25 and we have
25 and we have
9 equals
9
to
equals to
10,
10,
10,
10,
10
10
I3,
I3,
22
22
I1. So we
I1.
have
So we have
10
10
I3
I3
plus
plus
22
22
I1.
I1.
Hold on a second. Oh wait.
Oh wait.
I think
I
there's a
think there's a
mistake
mistake
here.
here.
This is
This is
I2,
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 I3,
I3,
I1.
I1.
Okay.
Okay.
So this is
So this is
I1,
I1.
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 So
So
so now
so now
um
um
what is the
is the
equation?
equation
10
10
I3,
I3,
22
22
I1,
I1,
22
22
I1,
I1,
25
25
equals to
equals to
28
28
I3
I3
plus
plus
22
22
I1.
I1.
So now
So
we
now
have
we have
two
two
unknowns.
unknowns.
So we need to
So we need to
remove
remove
one of
one
the
of the
unknowns.
unknowns.
We have to
We
remove
have to
one
remove
of the
one of the
unknowns.
unknowns.
So
So
let's remove
let's
this
remove
one,
this
right?
one, right?
So
So
let's
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 multiply this
multiply
by
this by
22
22
and let's
and let's
multiply this
multiply
by
this by
10.
10.
Can you see what
Can
I'm
you see
doing,
what I'm
right?
doing, right?
I'm making
I'm
it
making it
10 and
10 and
22.
22.
So I'm doing it
So
like
I'm
that,
doing it
right?
like that, right?
So we're
So
going to
we're going to
multiply it out.
multiply
So
it
we
out.
got
So we got
90
90
Okay,
Okay.
page.
Page.
Okay,
Okay.
so I have
So we
90
have 90
equals to
equals to
10 times
10
10
times
is
10 is
100.
100.
I3
I3
plus
plus
22
22
times 10 is
times
equal
10 is
to
equal to
2051.
2051.
So now
So now
25 times
25 times
22 is equal
22 is
to
equal to
550
550
equals to
equals to
28 times
28 times
22 is
22
equal
is
to
equal to
61653,
61653.
and then
And then
10
10
times
times
22 is
22
equal
is
to
equal to
220I1.
220I1.
So when
So
we
when
we're going to
we're going
now
to now
subtract,
subtract,
so we're going to
so we're going to
subtract,
subtract,
that's going to
that's going to
cancel.
cancel.
So we
So we
have
have
90
90
minus
minus
550 equals
550
to
equals to
negative
negative
460
460
equals
equals
to
to
100
100
minus
minus
616
616
negative
negative
516
516
I3.
I3.
Therefore
Therefore,
I3 is
I3
equal
is equal
to
to
negative
negative
4
4
6
6
negative
negative
460
460
over negative
over negative
516
516
equals to
equals to
I3 is
I3
0
is 0
comma
comma 8
1
1
amps.
amps.
That is
That is
I3.
I3.
So where
So
is
where is
I3? Let's go back
I3?
here.
Let's go back here.
I3 voltage
I3
is equal
voltage
to
is equal to
18.
18.
So the voltage
So
here
the
is equal
voltage
to
here is
18.
equal to
The
18.
voltage
The
here
voltage
is equal
here
to
is equal to
18 volts,
18 volts
because we know that
because we know that um,
in a
in
series
a
circuit
series circuit
the current
the
is
current
equal,
is equal,
and we know that
and we know that
in a parallel
in a
circuit
parallel circuit
the voltage is
the
equal.
voltage is equal.
So those two
So
voltages are
those two
going to be the
voltage are going
same.
to be the same.
So the
So
question
the
says
question
that
says
calculate the
that
current
calculate the
through the
current
30
through the
ohm
30
resistor
ohm
using
resistor
Kirchhoff's
using
law showing
Kirchhoff's
all
law
the
showing all
steps.
the steps.
So now we
So
just need
now
to
we just need to
find the
find the
current.
current.
So
So
if our
if our
resistor is equal to
resistor is equal to
18, let
18,
me check
let
again.
me check again.
So
So
our
our
resistor is
resistor is
18,
18
and our
and our
current,
current,
so R3 is
so
18,
R3 is 18,
I3 is 0
I3
comma
is 0
81,
comma
right?
81, right?
So our
So
voltage is
our
going to
voltage is
be,
going to be,
calculate the
let's calculate
voltage.
the voltage.
So the voltage is
The
equal to
voltage is equal to
I3
I3
multiplied by
multiplied by
R3,
R3.
and we're going to
And we're
get
going to get, um,
oh wait,
oh
sorry,
wait, sorry,
I made a
I
mistake
made a
here.
mistake here.
Yeah, this is
Yeah,
correct,
this is
but
correct, but
this is not
this is
correct
not correct because
we have
we have
a
a
voltage here
voltage
as
here
well.
as well.
So we have
So we have
to just
to
double
just
check
double
that,
check that.
and
And
we're going to
we're
get
going to
over
get over
here
here
0.82.
0.82.
So we have
So
0
we have
comma
0.9,
0.89,
0.89,
and our
and
resistor
our
is
resistance is
18,
18,
and our
and
voltage
our
is going
voltage
to
is going to
be
be
16 comma 0.5
16,05
volts.
volts.
that is
That is
our
our
voltage.
voltage.
So for
So
our
for our
voltage,
voltage,
the
the
voltage here
voltage
is
here
equal
is
to
equal to
16,
16,
and the
and
voltage
the
here is
voltage
equal
here is
to
equal to
16.
16.
So they
So
want
they
us to
want us to
find
find
the
the
current at
current at
30. They
30.
want us to
They want
find
us to
current
find
at
current at
30.
30.
So let's
So let's
calculate the
calculate the
current
current
to this
to this
question.
question. This is question.
So
So
resistor, resistor is
resistor
equal
is
to
equal to
20,
20,
sorry,
sorry,
30
30
ohms.
ohms.
Voltage is equal
Voltage
to
is equal to
16,05.
16,05.
What
What
is the
is the
current?
current?
So
So
our
our
triangle is
triangle is
V over
V over
IR,
IR,
and
and
our
our
I is
I
equal
is
to
equal to
V
V
over R.
over R.
So it's going to
So it's
be
going to be
5 over
5 over
resistor.
resistor.
30, so our
30, so
I
our I
30
30
is equal to
is equal to
16.05
16.05
over
over
30
30
equals to
equals to
0.0535
0.0535
amps.
amps.
So that
So that
is the
is the
end
end
of the
of the
question.
question.
Are there
Are
any
there any
questions?
questions?
Okay,
Okay,
so
so
someone
someone
asked,
asked,
can you please
can you please
explain
explain
again
again
V18?
V18?
Okay, so
Okay, so
V18 I was
V18
just
I was
using
just using
as an
as an
example to tell
example
you
to
that
tell you that
in
in
series the
series
current is
the
equal,
current
and
is
in
equal, and
parallel
in parallel
the voltage
the
is
voltage
equal.
is equal.
The 18
The
was
18
just,
was
I
just
just
I
used
just
it as
used
an
it as an
example, but
example,
the
but the
actual
actual
voltage is
voltage
actually
is actually
16.
16.
It's actually
It's actually
16
16
volts.
volts.
There's no
There's no
18. I
18.
was just
I was
using it
just
as
using
an
it as an
example
example
because
because
I thought there was
I
only
thought there was
one
only one
source, but there's
source, but
actually
there's
two
actually two
sources.
sources.
So
So
the
the
voltage cannot be
voltage
the
cannot be
same
the
in these
same
two
in these two
sources.
sources.
Um,
Um,
but
but
over here, the
the
current
current
divides.
divides.
So then
So
the
then the
voltage remains
voltage
the
remains the
same
same
between these
between these
two
two
lines over
lines
here.
over here.
So
So
the
the
16,
16,
to
to
calculate the
calculate the
16,
16,
we have to
we have to
first
first
find
find
I3.
I3.
Um,
Um,
this is
this
our
is our
I3,
I3,
right?
right?
And
And
this is our
this is our
voltage.
voltage.
So
So
we have
we
this
have
and we
this
have
and we
that,
have that,
right?
right?
Sorry,
Sorry,
wrong
wrong
analogy.
analogy.
We have our
We have our
I3
I3,
and we have our
and we have our
resistor
resistor
of
of
18.
18.
To
To
calculate
calculate
18, it
18,
is
it is
1 over
1 over
45
45
plus 1
plus
over
1 over
30
30
to the power
to the
minus
power
1
minus
equals
1
to
equals to
18.
18.
So that is
So
our
that is our
18
18
ohms, right?
ohms, right?
And then
And
we
then
use
we
the
use the
18 and we use I3
18
to get the
and we use
voltage of
I3
16
to
volts.
get the voltage of
So
16
16 over
volts.
here and 16
So
over there.
16 over here and
And
16
the
over there.
question wants us
And
to
the
calculate the
question wants
current.
us to calculate the
So we're going
current.
to use the
So we're going
16.
to use the 16.
We're going to
We're going
use
to
the
use the
16
16
um,
um,
16 volts
16 volts
and the
and
30
the 30
ohms.
ohms,
So we're going to
and we're
find
going
the
to find
current
the
of
current of
0.535
0.535
amps.
amps.
Let me just double check that.
Uh,
16
16
oh,
oh,
0.535.
535.
Okay.
Okay.
So
So
I think we
I
will
think we
end the
will
class
end the class um,
at this
at this
question.
question.
at about
at about
1:30
1:30
p.m.
p.m.
We will be
We will be
doing
doing
the
the
the next
next
questions.
questions.
So
So
are there any
are
other
there any other
questions?
questions?
Do you have any
Do
other
you have any
questions?
other questions?
I will be
I
here
will be here
for
for
the
the
remaining time
remaining time
that we have
that we have
and to
and
answer
to
any of your
answer any of your
questions.
questions.
Thank you.